In this lesson, we're going to talk about what is a rational expression and then learn how to multiply and divide rational expressions. So to begin with, what is a rational expression? Well, the simplest way to think of a rational expression, it's a ratio of two polynomial expressions. For example, 8 plus x divided by 13 plus x is a rational expression. Notice the numerator is a linear polynomial, and so in this case is the denominator. So the first thing that we're going to show you how to do today is we're going to show you how to simplify polynomial expressions. Rational expressions, I should say. What you want to do in simplifying rational expressions is A, you want to cancel out the like factors, and make sure you know how to factor, because that's why I gave you that formative yesterday, because you're going to have to do a lot of factoring in this chapter. So take a look at the rational expression 10x squared y divided by 15x to the fifth y squared. Again, these happen to be two monomials. So as you can see, they found the like factors. 10 became 2 times 5. 15 becomes 3 times 5. They wrote out the x squared as x times x. Here x to the fifth, notice the 5 x's they have there. And then you're canceling out like factors. So notice they cancel out the 5, two of the factors of x, and one of the factors of y. The only thing left on top, of course, is 2. And on the bottom you have 3 x to the third times y. Take a look at the second. 2x plus 8, a linear polynomial on top, and a quadratic on the bottom, but it's already in factored form. X minus 4 times x plus 4. So we factor the numerator. Remember, the only thing you can do with a linear polynomial is to simply pull out a GCF, the GCF being 2. 2 times the quantity x plus 4. Cancel out the entire factor. You can take out the entire polynomials, but you can't take out parts of them. 2 divided by x minus 4. Take a look at this example. Actually, two examples here. X squared minus 16 divided by x squared minus x minus 12 is our first example. So the first thing we want to do is we want to factor each of the polynomials. Notice I'm not canceling out the x squared because they're terms. So the first thing you have to do is you have to factor. Well, x squared minus 16, of course, is a difference of squares, so it's x plus 4 times x minus 4. The denominator, x squared minus x minus 12, x minus 4 times x plus 3. And then we're going to look to cancel out the like factors. In this case, we're looking for whole binomials. So our like factors are the x minus 4, so we're going to cross both of those out. And our final answer then becomes x plus 4 times x plus 3. Again, notice I don't want to cancel out x's because they're not factors, they're terms. You can either take out the entire polynomial, but you can't take out parts of it. Taking a look at example 2, 14 minus 2x. Again, we're going to factor, so the numerator we take out a factor of negative 2, leaving us with the binomial x minus 7. The denominator we take out the GCF of x, leaving me with x minus 7. Like factors of the binomials of x minus 7, so we cancel each of those. And we end up with negative 2 over x. Now that we know how to simplify rational expressions, we now want to be able to work with rational expressions, in our case, multiplying and dividing. So the first thing we're going to talk about is multiplying rational expressions. Take a look at this little bit fuzzy example. 4x plus 8 divided by x squared minus 25 times x minus 5 over 1. Well, remember that when you multiply rational expressions, just like when you multiply rational numbers or fractions together, it's numerator times numerator and denominator times denominator. Well, that's what we're showing you here. 4x plus 8 times x minus 5, we go straight across. X squared minus 25 times 1. Now, notice we didn't go ahead and FOIL 4x plus 8 times x minus 5 because we want factors. So 4x plus 8, GCF of 4, which we take out right here, x plus 2, x minus 5, x squared minus 25 is the denominator, it becomes x minus 5 times x plus 5. Again, 4x plus 8 over x plus 5 because the x minus 5's cancel. Take a look at the second example. 4x plus 8, x minus 5, x squared minus 25, 5x plus 10. They don't even bother to put them together, which is the way I would prefer to do it. I just immediately start factoring everything that I can. So 4x plus 8, pull a GCF of 4 out, leaving us with x plus 2. X squared minus 25, difference of squares, x plus 5, x minus 5. X minus 5, 5x plus 10, pull the GCF of 5 out. And notice they even got a little color for here. X plus 2, those are common binomial factors that we cancel out. Cancel out the x minus 5s, leaving the only thing left on top is the factor of 4, and then 5 times x plus 5. Let me back that up. Now, in your final answer, I know back here in the first example, they multiplied the 4x plus 2 and got the 4x plus 8. Here they didn't. You can go either way. I personally prefer it the second way that's here, and don't multiply back together. Next up, dividing. Well, you follow the same rules as you do with numeric fractions. Know how to multiply the polynomials, and always simplify your results. Remember, when you do division of fractions, you flip and you take the reciprocal of the second. That's the same thing we do. So look at this one here at the bottom. As you can see my cursor here. 3x divided by x plus 1 is one rational expression. 2x plus 4 divided over 5 is the second. We take the reciprocal of the second. So we take 2x plus 4 over 5 and we flip it. 5 over 2x plus 4. No like factors in anything here, so we just simply multiply it together. 3x times 5, 15x. X plus 1, 2x plus 4. Now, monomials, yes, multiply those together because it doesn't look right to leave it as 3x times 5. Make that be 15x, but you never really want to FOIL. Let's look at another example that I worked out a little more in detail. Here, you have two monomial rational expressions. So again, you flip the second one, 16xd squared over 9y squared z. That's what we're showing you right here to this part. Next, look for those like factors. So here, notice they're taking out the like factors of y. And unfortunately, those are the only two like factors in the entire problem. So 2x squared, 3z, because the y's are canceled, 16xd squared and 9y squared z. Multiply because they're monomials. 32, remember, product property of exponents, you add the exponents together. X cubed, d squared, 27, y squared, z times z, z squared. Take a look at this one. X cubed minus 8 over 4 minus x squared. So a cubic binomial, as a matter of fact, over a quadratic binomial. Here, quadratic trinomial, quadratic trinomial. Remember, the first thing you want to do is you want to take the reciprocal of the second expression. So we flip the second one. Remember, after you flip, it's no longer division, it's multiplication. Next, factor each numerator and denominator as completely as you can. Now, if you don't remember, x cubed minus 8, that's called the difference of cubes. So if you need to, Google it. Go back and look up difference of cubes. Google it and see how to do it if you forget. X minus 2, x squared plus 2x plus 4. Here, I take out the negative 1 because I always like to have that first coefficient be positive. Then it becomes x minus 2, x plus 2. Here, x squared minus x minus 6, well, that's x minus 3 times x plus 2. And here, all I can do is pull out a GCF of 3. Remember, it's not division anymore, it's multiplication. Move me out of the way. Next, look for the like factors. X minus 2, x minus 2. What else is like? Yeah, the trinomial. X squared plus 2x plus 4 and x squared plus 2x plus 4. Anything else? Yeah, don't forget the x plus 2's. So what do you have left? Well, on top you have x minus 3, negative 1 times 3 because they're monomials, negative 3. Or if you want, we really don't like to leave a negative in the denominator, so I just took the negative to the top and distributed it. Negative x plus 3 over 3. I'll take either one of those, and I think Math XL will as well. That is how we multiply and divide and simplify rational expressions.